Our solar system's dramatic secrets. The violent birth of our moon. Close your eyes and travel back in time 4.5 billion years. The Earth is not the serene blue marble we know. It's a half-formed molten sphere. Its surface, a global ocean of magma. The solar system is a chaotic shooting gallery of planetary building blocks. And then, from the void, comes Theia, a rogue planetoid roughly the size of Mars. It doesn't just pass by, it delivers a glancing blow to the infant Earth. The impact is beyond comprehension. It doesn't just shake the planet, it vaporizes a significant portion of Earth's mantle and completely obliterates Theia. A ring of superheated rock, metal, and vaporized material, glowing brighter than 1,000 suns, is flung into orbit around our wounded world. This ring, this torus of destruction, is the raw material for our moon. Over just a few hundred years, through the relentless pull of gravity, this debris coalesces, cooling from a ring into a single spherical body. This giant impact hypothesis explains why the moon is so dry, the water vaporized in the incredible heat. It explains why moon rocks are so similar in composition to Earth's mantle. Every time you look up at the moon, you are seeing a monument to the most violent and creative day in our planet's history. The day we gained a companion, and the Earth was truly born. The alien oceans in our backyard. We gaze at the night sky looking for signs of water on distant exoplanets, but we've been ignoring the aquatic worlds right in our own solar system. Let's start with Mars. Orbital imagery reveals ancient shorelines, river deltas, and canyons carved by catastrophic floods. Billions of years ago, a vast ocean may have covered a third of the red planet's northern hemisphere. But the real marvels are further out. Jupiter's moon, Europa. From the outside, it's a cracked, icy ball, but beneath that frozen crust, perhaps 10 to 15 miles down, lies a global saltwater ocean, 60 miles deep, containing more than twice the liquid water of all Earth's oceans combined, and it's kept liquid by the gravitational kneading from Jupiter's immense pull. Then there's Enceladus, a tiny moon of Saturn. At its south pole, colossal geysers of water ice erupt hundreds of miles into space, feeding Saturn's E-ring. This is a moon that is actively spewing its subsurface ocean into the void. These aren't just frozen rocks, they are dark, deep, aquatic abysses with hydrothermal vents on their floors and all the chemical ingredients for life. The search for alien life may not require a journey to another star. It may be waiting for us in the sunless seas of our celestial neighbors. Saturn's impossible hexagon. At Saturn's North Pole, there is a shape that defies all our intuition about how fluids and gases behave. It is a perfect, stable hexagon, a geometric storm 20,000 miles across, so wide you could fit two Earths side by side inside it. This isn't a cloud formation that comes and goes. It's a persistent, six-sided jet stream, a roaring river of air with winds screaming at over 300 miles per hour. How does a planet, a giant ball of gas, create and maintain such a perfect polygon? On Earth, weather systems are chaotic and swirl in circular patterns. Saturn's hexagon is a stark, beautiful anomaly. Laboratory experiments with spinning fluids can create similar, though transient shapes, but nothing on this scale or with this permanence. It suggests deep, hidden dynamics within Saturn's atmosphere, a fundamental physics we have yet to fully grasp. It is one of the most mesmerizing and perplexing sights in our solar system, a cosmic snowflake etched onto the face of a gas giant. Venus, Earth's evil twin. If you want a vision of a runaway apocalypse, look no further than the planet next door. Venus is a textbook example of a greenhouse effect gone mad. Its thick, crushing atmosphere is 96% carbon dioxide, trapping the sun's heat in an inescapable grip. The surface temperature is a consistent 867 degrees Fahrenheit, hot enough to melt lead. The atmospheric pressure is 92 times that of Earth's. Standing on the surface would feel like being a kilometer under the ocean, and those beautiful, reflective clouds that make Venus so bright in our sky, They aren't made of water vapor, they are clouds of sulfuric acid raining a corrosive drizzle that evaporates before it even hits the scorching ground. Yet data suggests that for the first 2 or 3 billion years of its history, Venus may have been a temperate world, with shallow oceans and a stable climate. Something triggered a tipping point. The water evaporated, the CO2 built up, and the planet began to bake itself to death. Venus is not just a hellscape, it is a warning, a stark reminder of how delicate a planetary climate can be and what can happen when that balance is catastrophically lost. Pluto's beating heart. When the New Horizons probe gave us our first close-up look at Pluto in 2015, it revealed a world of stunning complexity. But one feature stole the show, a vast, bright, heart-shaped basin named Tombaugh Regio. This heart of Pluto is more than just a cute shape. It is a dynamic geological engine. The left lobe, Sputnik Planitia, is a deep basin filled not with water, but with solid nitrogen ice, along with traces of methane and carbon monoxide. This glacier is immense, and its weight is so great that it has fundamentally altered the dwarf planet. Pluto has reoriented itself over millions of years, rolling over on its side so that this massive, heavy basin sits permanently opposite its largest moon, Charon. It's a process called true polar wander. Think of it like putting a heavy weight on one side of a spinning top. The top will wobble and reorient until the weight is at its equator. This is what happened to Pluto. Its frozen nitrogen heart is so heavy that it literally tipped the entire world over. That's the incredible dynamic power of this distant, frozen world.